Okay, so the next thing we're going to do is we're going to build a calibrate function. This is going to actually serve two purposes. One is going to help us calibrate a little bit further, and two, it's going to allow me to kind of give you an example of some of the ways that you can build shapes using the Drawbot. And I want you to think about the key here is we're going to be using lots of for loops. Okay, so this will give you a reminder on how a for loop works. And so we're going to build a function called calibrate that we can run. It's going to just draw like 3 squares. And when we draw those 3 squares, we want them to be basically as close to the same as possible. And we did the 1 meter forward already, which allowed us to calibrate the wheel diameter value. And then here we're going to use this calibrate function to calibrate this wheel base value. Okay, so for our calibrate function, we're going to scroll down. So I already built the skeleton right here. And so basically, a square means that you go forward and you're going to turn 90 degrees, and you're going to do that 4 times to build a square. Okay, and if you want to build 3 squares, you got to do that 12 times. So you're going to go forward, turn, forward, turn, forward, turn, forward, turn. Keep doing that. 3 squares would be 12 times. Okay, and so if we're going to repeat a function or a command like that a whole bunch of times, then the way that we write that in code is we use like a for loop so that we don't have to write literally the command 12 times. So we could say for. The way we do a for loop is we initialize the counter at 0. Okay, then we say what the maximum value for the counter is, so x is less than 12, and then we say x plus plus, so we tell it to count up. So there's our for loop. Okay, and all we're going to do is we're going to, for each time through the loop, we're going to go forward. Let's say our square is going to have a side length of 10 centimeters, so we'll go forward 100, and then we're going to turn left. If you want to make yours turn right, that's fine. Turn left 90 degrees, and there you go. And then when we're done, since it's in the setup, we want to use our done function to turn off the motors. And there you go, there's your calibrate. Okay, so this function right here draws 3 squares, and that's it. Okay, and now what you're going to do is you're going to run it, and you want it to get as close to 3 full squares as possible. If it's giving you less, or if the trick here is to look at the angles. If the angles are too wide, or if they're too short, or too narrow, I guess. And you can adjust this value right here to try to narrow it in on an exact value. And you can test this and verify it, but I believe that if the angles, if it's not turning a full 90 degrees, then you might want to make this value bigger. And if it's turning more than 90 degrees, you want to make it a little bit smaller. Okay? And this only works if if you calibrated the wheel diameter already, doing that 1 meter forward. Okay? And if you're noticing that it's not, you're starting to like lose, if your Drawbot is not giving you the same like precision that it was when we first started, so like down the road, you can redo these calibrate functions, or you can redo this calibration process in case the wheels like got a little bit smaller, or maybe the wheels came loose. And so those are things that you can do to recalibrate it over time. These are really the 2 values that you're going to use to dial that in.